So this is problem 8.6.10, calculating the inverse of a matrix using the adjoint method. So from the adjoint method, if this is A, the inverse of A is 1 over the determinant of A times the transpose of the cofactor matrix, and we'll write the cofactor matrix as C11 to C1n, if A is an n by n matrix, to Cnn to Cn1. And then this is the transpose. And so we know how to calculate the determinant. In this case, determinant of A is 78. 78. And so all we need to calculate is the cofactor matrix. So remember from doing cofactor expansion, the cofactor ij, Cij, is -1 to the power I plus j times the minor determinant ij, where the minor determinant is the determinant of the matrix consisting of all rows except for I and all columns except for j. So let's go ahead and start calculating those. So C11 is -1 to the power 1 plus 1 is +1. So +1 times the minor determinant 0, -2, 4, 0. C12 is -1 to the power 1 plus 2, which is -1. So negative times the minor determinant 3, -2, 1, 0. And C13 is -1 to the power 1 plus 3 is +1. So 1 times the minor determinant 3, 0, 1, 4. Okay, so C21 is -1 to the power 2 plus 1, that's -1, times the minor determinant -1, 0, 4, 5. -1, 0, 4, 5. C22 is positive, the minor determinant 2, 0, 1, 5. 2, 0, 1, 5. C23 is minus the minor determinant 2, 4, 1, -1. 2, 4, 1, -1. And then computing the last row of cofactors, C31 is positive, the minor determinant 2, -2, sorry, -1, -2, 0, 5, -1, -2, 0, 5. C32 is the minor determinant, negative the minor determinant 2, -2, 3, 5, 2, -2, 3, 5. And C33 is positive the minor determinant 2, 0, 3, -1. 2, 0, 3, -1. And so if we compute all of these real quick, this is, I'll do this in red, this is 8, this is 2, this is 12, this is 20, this is -5, this is 8, plus 1 is 9, -9, This is positive 2. This is negative 4 minus 15 is negative 19. Negative 19 is positive 19. And this is positive 3. So our cofactor matrix then is, so 1 over determinant of A is 78. 78 times the cofactor matrix 8, 2, 12, 20, negative 5, negative 9, 2, 19, 3. Of course, we want the transpose of this matrix. So to calculate the transpose of a matrix, you swap all of the columns for the rows. You can also think of it as rotating about this diagonal right here. So if we do that, this is 1 over 78 times 8, 2, 12, 20, negative 5, negative 9, 2, 19, 3. I would leave the inverse matrix like this, because moving this fraction inside can get pretty messy. And so I would just leave it like this. And so this is A inverse.